So when we talked about our two conclusions about whether or not we reject the null hypothesis, it comes down to evaluating if p-value is small or not small. Now, small itself is kind of vague, and that's where we went with the obvious scenario of p-value of 0, definitely small, so we knew to reject that null hypothesis. But what if we had a p-value of 0.04 or a p-value of 0.1? At what point does it become a small probability? The difference between a 4% chance and a 10% chance? To some people, 10% might be a small chance. To some people, 10% might be a high chance. So with that, we need a cutoff value. And that is called our significance level, which we use the symbol alpha for significance. It's this significance level that will be the cutoff for what's considered small and not small, which creates this threshold for which we reject that null hypothesis. Now, the most common value that's used is alpha equals 0.05. And in fact, sometimes with these hypothesis tests, they won't even state what significance level to use. If they don't state a significance level, use 0.05. Some other values you might see 0.1 or 0.01. Basically what this does is where 0.05 relates to 5% significance, and here's 10% significance, and here's 1% significance. It's setting the level for if we are lower than that value, we reject the null hypothesis. So if our p-value is less than or equal to whatever alpha is, we reject the null hypothesis. And that's where getting a p-value out in that example of 0 is the obvious case, because 0 is going to be smaller than any of those values. But now what this does is it creates a rejection region. So for example, let's say we were doing some right tail test. And we decide to use a significance level of 0.05. What that does for our distribution is it sets this area where we're going to reject our null hypothesis. And it creates, if we're doing a right tail test, it would create an area to the right where over here we would have 5% of our information. And over here we'd have 95% of our information. So it's coming from setting alpha in the tail. And what would happen is if we land on this right-hand side, we land anywhere in that region, we would reject the null hypothesis. Because if we land over there, we're going to have an area, a p-value that's smaller than 0.05. If we land anywhere to the left-hand side, we would fail to reject the null hypothesis. So it gives us this cutoff mark for where we would reject and not reject. It comes down to comparing two numbers. We want to end up with this comparison of p-value and significance level and look at which is smaller. If p-value is small, reject the null. So that's what's happening on this right-hand side. That is where p-value is small. And we could work with these other significance levels, and as you can see, it would change this area. So if I went to use a significance level of 1%, what that would do to my graph here is it would push out this kind of spot where I am starting to reject and fail to reject further out into the tail, so that I'd only have this 0.01 spot, which means anywhere to the right I would reject, anywhere to the left I would fail to reject. Now, this can be kind of confusing because we would call this 1% significance, which makes it sound like it's low significance. However, if we had this scenario and we ended up rejecting the null hypothesis, that's actually more significant. This would have very high significance if we rejected at that level. It's because it's so difficult to reject a null hypothesis in that scenario that we'd have to have really extreme samples out there in the right tail in order to reject. But as we use higher percentage significance, this is so confusing, but if we have higher percent significance, it's kind of the significance of rejecting the null hypothesis decreases. So with that, think about having the significance level as setting this area under the curve and how it's changing the difficulty of rejecting that null hypothesis. So with this information, what we could do is just given a p-value, figure out whether or not we reject the null hypothesis. So with these, we're going to look at whether or not we do that. They don't state a significance level here, so what we do is just assume 0.05. So if they don't say anything, use 0.05. So with this first one, we're talking about this pollution emission standards. They have 1,500 cars. It's the same example before. And they ran a hypothesis test and got a p-value of 0.0009. Now what we want to do is you take that p-value and just write the significance level right next to it. And what you want to do is figure out what symbol goes between them, which is small, which is large. Now in this case, p-value is small. So we're going to see p-value is small, which means p-value small, we reject the null hypothesis. Because if we think about our null and alternative here that we set up in that previous video, that p is 0.8 and we're trying to prove that p is less than 0.8, when we took our sample had a very low probability of occurring, which means this null hypothesis probably isn't true. So we want to reject that null, and what we do is we have evidence for the alternative. So what we could claim here, if we want to make a full conclusion, is we state our p-value. So with a p-value of 0.0009, we have evidence that that proportion is less than 0.8. There is evidence that less than 80% of their fleet meets emission standards. So the wording here, there's three pieces at work. We state our p-value. Because we rejected the null, we do have evidence. Then the rest of this wording is the wording for the alternative hypothesis, which I actually just copied from in the sentence above there. So that's how we make our conclusion. We can come to that conclusion just by comparing p-value and our significance level. Let's look at this next example. This is where our null and alternative was that we assume it is 0.148, and the alternative is that it is not 0.148. Now this says we have a p-value of 0.273, and we're comparing that to a significance level of 0.05, and we want to figure out which is larger. In this case, our p-value is big. So p-value is not small here, which means we cannot reject that null hypothesis. Which means there isn't evidence for the alternative hypothesis. So, with this, what we have to do is we just say, we can't claim this. We can't claim that alternative hypothesis. We have to be very careful of with our wording of the conclusions, though, is that we haven't proven the null is true. We don't know if that proportion is exactly 0.148. All we know is that it's just not significantly different from that number. But maybe it's 15%, maybe it's 14%, maybe it's close by that number. We don't know that. All we know is that it's not significantly different. So that's where in the wording of our conclusions, we're always talking about our alternative hypothesis. So we want to talk about this idea of not having evidence for the alternative. So we still state our p-value because that's our level of evidence. So with a p-value of 0.273, there isn't evidence the county, county has a different poverty rate than the rest of the US. So our wording here, we state our p-value. We would have to say there isn't evidence in this case because that p-value is not small. And then the rest of the wording is about our alternative hypothesis. So again, we don't want to talk about the null hypothesis. It's all about whether or not we've proven that alternative, which in this case, we just couldn't. Our evidence wasn't strong enough. All right, then with C, we have drugs that prevent seizures sometimes, have unwanted side effects such as depression. A researcher wants to study such a drug and look for evidence that such side effects exist. Now this one's a little different. It's not necessarily testing a proportion, but we could get an idea of what we assume is true and what we're trying to prove. And even in here, they state our alternative hypothesis, what the researcher wants to study, and they want to look for evidence that the side effects exist. So our alternative hypothesis that we're trying to prove is that there are side effects. And then with our null hypothesis, what we would assume would happen with drugs is we would assume no side effects. So to put all those little side effects on the side of a bottle that you pick up at the drugstore, they have to have significant evidence that they occur. So we have a p-value of 0.06, and we want to compare that to our significance level of 0.05 and figure out which one is larger. And sometimes it can be helpful if you're having a tough time with just seeing with the decimals which is larger, which is smaller. Sometimes it's helpful to change them into percentages. Like this represents a probability of 6%. This represents a probability of 5%, so which has the higher percentage? The 6%. And like up above here, it was comparing 27.3% to 5%. So 27.3% is much larger. With this first one, it's a 0.09% versus 5%, so a much lower probability with that 0.09%. Sometimes just changing them to percentages can help a lot. So p-value is large. So p-value is not small. So we have a similar scenario that we saw in B. So we would fail to reject the null, which means no evidence for the alternative. So there weren't significant side effects. So for our conclusion, what we would say is with a p-value of 0.06, there isn't evidence of side effects, or at least significant side effects to make that conclusion. So that's how we evaluate p-value once we get that number out and making our sentence conclusion. What we're going to do in the next video is go through how do we set up all these steps and then go through some examples.